Here we are going to find the first term and the 100th term of the sequence whose general term is a sub n equals negative 1 to the power n plus 1 times the quotient of n and the quantity n plus 4. So this time our a sub 1 will be the product of negative 1 to the 1 plus 1, which is 2, times 1 over 1 plus 4, which is 5. So this will be a positive term because negative 1 squared is 1. So the first term is 1/5. A sub 2 is going to equal negative 1 to the 2 plus 1, which is 3. The fractional factor will be 3 over 3 plus 4, 2 over 2 plus 4. So 2, because our n is 2, 2 plus 4 is 6. So a sub 2 is an even numbered term, but it is going to have a negative value because there is an odd exponent on the negative 1. So it reduces to the fraction negative 1/3. For a sub 3, we'll have negative 1 to the even power 4. And we'll have 3 over 3 plus 4, which is 7. So negative 1 to the 4th is positive 1. Positive 1 times 3/7 is 3/7. And a sub 4 will be negative 1 to the 4 plus 1, which is 5, times 4 over 4 plus 4, which is 8. So this is going to be a negative term, and it's going to be negative 1/2 when the 4/8 is reduced. For a sub 100, we will have negative 1 to the 101st power, because it's the number of the term plus 1, and then the fractional factor will be 100 divided by 104, 4 more than n. So negative 1 to an odd power, this term is going to be negative, and it reduces to 25 over 26. In our second example, a sub n, the general term, is 9 times n plus 6. So we can use a table of values to list the first 10 terms. So we'll have a, and we'll have a sub n, where a sub n is 9n plus 6. And n goes from 1 to 10. So the first term will be 9 times 1 plus 6, which is 15. The second term, 9 times 2 plus 6, 18 plus 6 is 24. 9 times 3, 27 plus 6 is 33. 9 times 4, 36 plus 6 is 42. 9 times 5, 45 plus 6, 51. 9 times 6, 54 plus 6 is 60. 9 times 7 is 63 plus 6, 69. 9 times 8, 72 plus 6 is 78. 9 times 9, 81 plus 6 is 87. And 9 times 10, 90 plus 6 is 96. Now, in the second part of this problem, we are to graph the terms in this sequence. So we'll be graphing the point 1, 15, and then 2, 24, then the ordered pair 3, 33, etc. Notice that the difference between these terms is 9. There's a common difference, and notice in terms of functions that y equals 9x plus 6 would have been a linear function. These terms in the sequence are all going to be along the same straight line, but they will be discrete and not connected. And so let's look at the point tool in WebAssign, and we can type in the points. So 1, 15, enter. And then I'll hit the point tool again. 2, 24, whoops, now we've got to be careful. 2, and then go over to the second coordinate for the 24, enter. Back to the point tool, 3, 33, enter. 4, 42, enter. 5, 51, enter. 6, 60, enter. 7, 69, enter. 8, 78, enter. 9, 87, enter. Back to the point, and lastly 10, 96, enter. So this is what this sequence of points looks like graphed on the number line. Let's go and look at the next problem, which is 14 over n. And so here again, we're going to be looking at n and a sub n. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll have 14 over 1, 14 over 2, and we will either leave, or we will leave these as fractions, not decimals, because the decimals would be only approximate in some cases. So let's reduce what we can reduce. So we have 14, we have 7, 14 thirds would stay as 14 thirds. We have 7 halves, 14 fifths, 14 sixths would become 7 thirds, 14 sevenths would be 2, 14 eighths would be 7 fourths, 14 ninths, and 7 fifths. And so when we go to graph this one in WebAssign, we'll have one, 14 over 1. I'm sorry. The first term is 14, which is 14 over 1. So 1, 14, enter. Then pick the point again. 2, and this is 14 halves, 4, so 7, enter. 3, 14 thirds, enter. 4, 14 fourths, which is 7 halves. Enter. 5, 14 fifths. Enter. 6, 14 sixths, which is 7 thirds. Enter. 7, 14 sevenths, which is 2. Enter. 8, etc. I think I'm going to probably run out before the time is over. So this would be 14 over 8, which would be 7 fourths.